సైలెంట్ అంట నో ఫుడ్ నో డ్రింక్ అంతే
Namaskar. Once again, we welcome you all to Nehru Planetarium, this time to the Sky Theatre of Planetarium. And before we start with the film, here we are going to see what we call Sky Tonight. So in case if it turns out to be clear tonight, what bright stars and planets could be seen and how we can identify them. But even before that, I would like to remind you about these things. So please take care of them. And now, let us begin with the present position of the sun in the sky. And soon we will see sunset. And as we all know, sun sets in the west, so west is somewhere here. And whenever we are facing west, onto our left will be south, where we have mentioned date and time for your reference. And if we look at the horizon, here we see Gateway of India, that is South Mumbai. And onto our right will be north, where we see here Worli's TV Tower. Many people think this is Eiffel Tower of Paris, but this is Doordarshan TV Tower. And of course, behind us will be east. We see here airport area between Santa Cruz and Andheri. And where the sun went down is Girgaon, Chowpatty and Marine Lines area. So now we know that this Ashtamika Chandrama. And then little east of that, we will see planet Saturn. And then slowly, other stars will start showing up. Unfortunately, city dwellers never get to see good skies because of light pollution. So let us do one thing. Let us go away from the city, somewhere on mountaintop observatory, and see the sky from there on a moonless night. Then the sky would appear to us like
wow
this. Thank you so much.
very nice
Where you will not only get to see bright stars, but even faint stars, star clusters, meteors or shooting stars, and our home galaxy, the Milky Way. Our ancestors saw some figures among these stars and we call them constellations. So here we see Scorpius constellation, Vrishchik, which is also zodiac. And here in the northern part of the sky we see Big Dipper, part of the constellation Ursa Major. In India, these 7 stars are called Saptarishi, and they are given names of ancient Indian sages, and they are Kratu, Pulaha, Pulastya, Atri, Angiras, Vashisht, and Marriage. And we have all learned in school that if we join the first two stars and extend that line in the north, then we get pole star, Polaris or Dhruvatara, the exact north indicating star. When first star charts were created, they had some 48 constellations and they were associated with some mythological stories to keep them in mind. Later on, people added more constellations, and today the entire sky is divided into 88 constellations. And for simplicity, they are divided using straight lines. After this short introduction of the sky, let us come back to our sky. So tonight at 8 p.m. we will have these stars in the sky. But before we start the sky observation, we will go a little off track because lately people have been asking us about James Webb Space Telescope. So the telescope looks like this, and it mainly works in infrared part of the spectrum. What it means is it is very good in studying gaseous and dusty regions in space. And sure enough, the first picture it gave us back was a star forming region in southern part of the sky, and the stars which are never seen before visually has started showing up. So using this telescope, today we are able to understand very early stages of star formation and also planet formations around these young stars. Also, for the same reason, it is going to be very useful in studying our gaseous giants, for example Jupiter, almost on a regular basis, regular interval of time. And when a sun-like star exhausts its fuel, it never undergoes any kind of explosion. All it does is it leaves its outer atmosphere in space and the core implodes. It does not explode but implodes to form white dwarf star. Such objects are also been studied with greater detail thanks to the ability of James Webb. Now in the next slide, we are comparing this telescope with our previous observatory, which is still functioning and works in visible part of the spectrum, that is Hubble. Now the diameter of Hubble is only under 2.5 meters. Compared to that, James Webb is very large telescope. So obviously it can see much deeper in space than Hubble can do. After that, we come to our sky and we notice at 8 p.m. planet Saturn has come up very high in the sky, and Jupiter can now be seen clearly in the eastern sky. Then we look in the northern part of the sky and we see here 5 stars making zigzag constellation Cassiopeia or Sharmishtha Taramandal. So in the absence of Big Dipper, that is Saptarshi, we can make use of this constellation to identify pole star. All we need to do is we take the southernmost star to be the first one, we join the 4th star, and from the center of that line we drop a perpendicular in the north and we get Polaris again. From there we look down south and we see here constellation Sagittarius, Dhanu Rashi. Now some stars of this constellation, which are almost of the same magnitude or brightness, if we join them with imaginary lines, we get this interesting shape, something like a teapot. So it is called teapot asterism. Asterism is part of complete constellation. And just little west of the teapot, or you can say the spout of the teapot, lies the center of the Milky Way, the galactic center, where we have discovered a supermassive black hole.
Black hole.
There we go. And this picture is product of many pictures put together by network of radio telescopes around the world called Event Horizon. And what you see, the bright patches around are actually some violent activity going on the other side of the black hole, and we are able to see that on this side because of bending of light. And the black hole is somewhere in the center. Then we move little northward again, and in the western portion of the sky, and we see this very bright star, Vega or Abhijit. This is 28th nakshatra. By the way, nakshatra means part of the sky in which the moon remains for a day. It is in the constellation of Lyra. Now imagine we have our own telescope and we point the telescope right here, then we get to see a star which has shaded its outer atmosphere to contract and become white dwarf star. This object is called ring nebula, for a trivial reason that when we look in the telescope, we actually see the ring structure. From there, we move in the eastern part of the sky. Little north of Saturn, we see here 4 bright stars, which we can join this way. And naturally, we get a square. So this is great square of Pegasus constellation. Pegasus, the flying horse. The northeastern star of the square, however, is part of the constellation Andromeda, the constellation in which lies the nearest galaxy to the Milky Way, and that is Andromeda Galaxy.
Oh my god. That is very nice.
Now we advance the time and see the sky as it will be at midnight, when Jupiter will be almost overhead, which is at the moment in the constellation of Aries or Mesh Rashi, the first zodiac sign. And this zodiac sign also houses the first nakshatra, Ashwini, which is made using these 2 stars of Aries. Then we look in the mid-eastern sky and we see Orion constellation, the hunter. The 3 stars in the row are the belt stars of Orion, and there are 2 stars, bright stars towards north. These are the 2 shoulders of Orion, and another pair of stars almost equidistant on the other side are the legs of Orion. And just little south of the belt stars lies Orion Nebula, the closest star-forming region to solar system. And in our telescope, the view will be something like this. But of course, minus the colors. Okay, now let us make use of these 3 stars to identify few more stars around. So if we join them and extend that line in the west, then we get this reddish color star called Aldebaran or Rohini Nakshatra. And further down, we get this open star cluster, Pleiades or Pleiades, however you want to say it, Kritika Nakshatra. To the naked eye, some 5 to 6 stars are visible in this cluster, and in our telescope, you will see many more. Again, we go back to the same three belt stars of Orion. This time, after joining them, we move in the east and we get the brightest star of the night sky, Sirius. So now there is this misunderstanding. Many people think that the brightest star of the night sky is Pole Star. No, it is seriously Sirius. Now we advance the time again and see the sky as it will be at 5 a.m. when right overhead will be zodiac sign Gemini. The heads of the Gemini are known as Punarvasu Nakshatra in India. So if we join them and also take along another pair of stars just little in the south, almost parallel to them, then we get the region of the sky which is called in India Gateway of Heavens. Gateway of Heavens, because as seen from the earth, all the planets, the sun and the moon, they always pass through this gap. So actually that is the plane of the solar system. Then we notice very bright object in the east, that is planet Venus, which is in the constellation of Leo, the lion, and the brightest star of Leo is Regulus, Magham. Now this star happens to be exactly on the belt of ecliptic, and that's why occasionally it gets covered by the moon. It's a kind of an eclipse called occultation. And then little later the sun will come up and the next day will begin.
Good morning.
So good morning everybody.
Very good morning.
So now we'll enjoy the movie, that is Cosmic Life. In case of any questions, please feel free to ask me after the film. My name is Jatin Rathod. Thank you. Dhanyavad.
Close up जरिए वो चलिए.
The sight of the stars makes me dream, said the painter Vincent van Gogh. By day we can forget that we live in a vast and mysterious universe. But at night, gazing at the starry sky fills us with wonder and questions. What is the universe? How big is it? Will we humans ever travel to deep space? Are there alien beings out there looking at the stars just as we do? Is someone in distant space looking back at us right now? The question has intrigued people through the ages. Is life a miracle unique to the earth? Or is there life everywhere in the universe? The answer to this question of cosmic life lies in our understanding of the origin of the universe, the formation of the solar system, and the evolution of life on Earth. To understand the nature of the universe, let's go for a random walk in the sky. The Orion constellation is a good place to start, because it reveals the challenges to life in a violent universe. Some stars, like Rigel, are gigantic infernos compared to the Sun. Rigel is 50,000 times brighter. The red giant Betelgeuse is about 250 times larger than the Sun. It's a dying star that has massively expanded before fading. One day, our life-giving sun will also become a red giant and expand till it reaches Earth's orbit and even beyond, destroying all life on Earth. Don't worry, this won't happen for billions of years. The death of a star can be spectacular, but there are also stars being born in fairy spectacles. A telescope view of Orion's belt reveals a dazzling cloud of gas and dust called the Orion Nebula, a birthplace of countless stars. It is believed that our Sun, with all its planets, was formed from a similar cloud about 5 billion years ago. As we walk away from Orion, we find stars much younger than our Sun, including Sirius, the brightest star in the sky, nicknamed the Dog Star. In fact, Sirius is a double star with an invisible companion called the Pup. Nearby, we come upon a comparatively young star cluster called the Pleiades in the constellation Taurus. Sirius and the Pleiades were formed about 100 million years ago, when there were dinosaurs on Earth. In contrast, our Sun, 50 times older, could be called a great-great-grandfather. We can walk by another example of colossal violence in the constellation Taurus. The Crab Nebula is a gaseous cloud, the remains of a star that exploded. When this supernova burst 1,000 years ago, people on Earth saw it as a very bright star that looked like a crab. It was visible for many days, even during daytime. If there were living things nearby, the sudden explosion would surely have surprised them. We don't have to worry about such a surprise. Our Sun is too small to become a supernova. Would the sky look the same to other beings in space as it does to us? We know that in some places the view would be very different. In the constellation Sagittarius, for example, there is a globular cluster of more than 500,000 stars, most of them brighter than Sirius, the brightest star we can see. The cluster is one of the most beautiful sights in the sky. For any intelligent beings in the Sagittarius neighborhood, it would be overhead constantly flooding the night sky with brilliant light and color. Imagine such a view night after night. When we on Earth face the Sagittarius constellation, we are actually looking towards the very center of our own galaxy, the Milky Way. We are just a tiny part of the galaxy. The Milky Way has more than 100 billion stars. But our galaxy is just part of a cluster of 20 other nearby galaxies. And the cluster is a part of a supercluster of thousands of galaxies. And the supercluster is a part of a supercluster, and so on. Some believe there is a filament-like structure to the universe made up of more than 100 billion galaxies in all. It is hard to comprehend the enormity of the universe, whose total mass in tons is estimated to be the number 20 followed by 48 zeros. 20 trillion tons. It is hard to imagine such a prodigious amount of matter, let alone explain how it all came about. It is very difficult to know exactly how the universe began. Some believe that it neither had a beginning nor will it have an end. Others think that our universe was born about 15 billion years ago with a gigantic explosion, the Big Bang. As the Big Bang began, all the matter we see in the universe formed a primordial fireball, trillions of degrees hot and so incredibly dense that a teaspoon of it would weigh billions of tons. When this fireball suddenly expanded, it created space and dispersed matter through it. Over time, as matter cooled, gravity concentrated some of the matter into the first stars and galaxies. There were no witnesses. Life had not yet arrived. The first stars born were composed mostly of hydrogen and helium. But the hot core of these stars cooked the atoms of these light and abundant elements into the dozens of heavier elements we find in the universe today. When these first generation stars died, all of these elements were released into interstellar space, where they formed the star generations that have followed ever since, making the universe richer and richer in heavier elements. Our Sun, probably a third-generation star, is made up mainly of hydrogen, but it also contains heavier elements produced by the previous generations of stars. The Earth and other planets in our solar system were formed as byproducts left over from the formation of the Sun. All the matter that makes up our world, from the water we drink to the food we eat, the clothes we wear and the houses we live in, everything, including the ingredients of our own bodies, once existed in the hot interiors of massive stars and is then thrown into the cold emptiness of interstellar space. We are all made of stardust, as the poets have written. Your right hand may contain elements from one collapsed star, and the left hand matter from a different star. Said the astronomer Carl Sagan, the cosmos is within us. It appears that whenever a star is formed, planets are also likely to form. If this is true, there could be hundreds of billions of planets in our Milky Way galaxy alone. And with over 100 billion galaxies in the whole universe, there could be trillions and trillions of planets. Even among about 50 of the stars nearest to us, astronomers have found some evidence that 3 of those planets, Epsilon Eridani, Tau Ceti, and Bernard star, have planets circling them. The orbiting Hubble Space Telescope captured the first visible light image of a planet around another star, and has detected planets in deep space as well. Given all that the matter in the universe has a common origin in the Big Bang, it is reasonable to assume that if life could erupt in one small planet of an average-sized star in an unremarkable galaxy, it could also have arisen elsewhere. Maybe the whole universe is teeming with life. Millions of stars were formed before the sun, presenting the tantalizing possibility that intelligent beings could have evolved in our own galaxy long before Earth even came into existence. If there's life out there, why has no one communicated with us? The distances that separate us from the stars are so enormous, it is virtually impossible at present to establish contact even with the planet of a nearby star. If we send a radio signal today to the nearby star Sirius, the signal would not reach it for about 8.5 years. If on a planet circling Sirius, there were intelligent life able to understand a message, their reply would take another 8.5 years to reach us. 17 years to find out if our message was a waste of time. Communicating with more distant planets could take centuries. That did not deter American astronomer Frank Drake, who sent radio messages to a globular cluster in the Hercules constellation, 24,000 light-years away. He hoped that at least one of its 500,000 stars might have a planet with advanced beings able to send a return message. Astronomers such as Drake, Carl Sagan, have also tried to detect signals coming from any of the 500 nearest stars, without success so far. If we ever do receive signals from an extraterrestrial civilization, it will be the biggest news story in history. Radio signals are one thing, but what are the chances we could actually venture out into deep space someday and meet extraterrestrial beings? With present-day technology, a spacecraft can travel about 50,000 kilometers per hour. If we set out today for the star nearest to us, Alpha Centauri, it would take about 100,000 years to reach it. What if we travel at the speed of light? It would take only 4.5 years. But it's impossible to go that fast, as Einstein proved. To reach the speed of light in a spacecraft weighing 1,000 tons, we would need as much energy as the entire modern world will consume in the next 5,000 years. Imagine, however, if the future brings us new sources of energy and miraculous technologies for faster travel. Maybe we could someday journey to the nearest star in just a few hundred years. It is not unthinkable. Who could have imagined when the Wright brothers first flew that we could have a reusable space shuttle in less than 80 years? Let's daydream about an historic event in the future, which has been briefly delayed.
Our satellite solar power station was hit by a meteorite this morning. The microwave transmitter was damaged. A repair craft has reached the station with technicians, and the transmitter is expected to be operational within a few hours. The Minister of Energy has conveyed her regrets for the power cut due to this accident.
The delay is minor, and preparations continue for a momentous space mission. The Indian spaceport is about to launch the 1,000-ton spaceship Chandragupta, named for an ancient Indian emperor. The goal: to make the first direct contact with a civilization beyond Earth, a journey that will cover 100 trillion kilometers. the historic departure will be telecast live around the world. Beyond the spaceport, millions have assembled for a glimpse of the unique spacecraft as it sets out on the first ever voyage to an extraterrestrial civilization. Chandragupta's trip will take 600 years. The destination is the star Epsilon Eridani, from which radio telescopes around the world have been receiving intelligible and continuous radio signals. All the astronauts, 123 men and women, have entered the spaceship, and it has been sealed. The world bids farewell to a crew of heroes who dare to embark on a journey of no return. The present astronauts will spend all their lives in the spacecraft, as will their children and grandchildren, and so on. After centuries of travel and many generations, the mission will be completed by distant descendants of today's crew.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off! I hope all of you are comfortable. We had a fantastic launch, and we are about to see some fascinating sights. At our hyper-cruising speed, we are already approaching Venus. Breakfast will be served when we pass Jupiter. We are descending to give you a good view of the desert planet. According to our gauges, the surface temperature on Venus is 860 degrees Fahrenheit, hot enough to vaporize any liquid water and even to melt lead. The clouds are made of sulfuric acid. When it rains on Venus, the surface is so hot the droplets evaporate before hitting the ground. Ahead, the red planet Mars. It's also a desert planet, but Mars is not boiling hot like Venus. It's 70 degrees right now, but it will be 100 degrees below freezing tonight. You can see a popular resort filled with tourists from Earth on a Martian holiday. It may not be Barbados, but the view is unbeatable. We are feeling the gravitational pull of Jupiter now. As you can see out the windows, this giant planet is hidden beneath dense cloud layers composed mostly of ammonia and sulfur. The orange spot is a hurricane-like storm that had been raging for at least 300 years. The storm is so huge, 3 Earths could fit inside it. You'll be surprised as we fly by Saturn and its famous rings. From above, the rings look like silky smooth, but up close, you can see they are actually layers of ice-covered rocks buried inside from tiny pebbles to huge boulders. Ahead, Titan, the moon of Saturn, larger than the planet Mercury. Its nitrogen-rich atmosphere leads scientists to speculate that there may be some form of life on Titan. Unfortunately, we won't pass the outer planets. From Titan, our route heads out of the solar system. We're entering interstellar space. If you look backwards, you'll see the retreating sun. The sun we've known and depended upon all our lives now looks no different from any other star.
In the hauntingly beautiful, immense void of interstellar space, days seem to fly by. Soon the crew is celebrating their first anniversary in space.
Radar shows a strange object directly in our path. No problem though. We have overtaken something sent out here hundreds of years ago by our ancestors. It's the Voyager spacecraft. Among its contents is a disk filled with sounds from Earth, everything from Bach and Chuck Berry to Vedic hymns. In case aliens intercepted Voyager, the hope was that music might serve as universal language.
And the spaceship Chandragupta moves on and on and on. Years turn to decades and decades turn to centuries. New generations are born and they spend their entire lives in the spaceship, educated by their parents and in turn teaching their children about the aim of the mission and the nature of the universe. They are the first youngsters in history who are space-born, space-raised, and space-educated. Imagine yourself as one of these children. You are in an astronomy class, and this is what you are learning.
It is interesting to note that the objects around us in the cosmos behave in some ways like human beings. They have their time of birth and hour of death. Some are lonely and some have companions. Some are small and some are giants. What is true of stars is also true of the galaxies made up of billions of stars. Galaxies come in all shapes and sizes. Like people, some even crash into one another. And like predators, some galaxies can swallow other galaxies in their neighborhood.
Oddly, though the people in the spaceship hail from Earth, they have never seen their own planet. They have never set foot on any planet. The spaceship is equipped with a powerful telescope, but the Earth is too small to see, and the Sun is just one of billions of stars. Finally, a long-awaited day is at hand. The centuries of monotonous existence in the spaceship have suddenly turned to excitement. It has begun with a discovery in the control room.
Ladies and gentlemen, I am happy to announce that we have spotted a planet ahead near the star Epsilon Eridani. More importantly, we have received radio signals from it, and we are calibrating our telescope to get detailed images of the planet. It certainly appears that we are about to meet some form of intelligent life as our ancestors dreamed.
How big do you think this planet is?
It seems to be a very small planet. From my preliminary calculations, it has only 1/10 the surface area of Earth.
With such low gravity, the beings there must be very thin and tall.
Oh, hold on. I calculated wrong. I divided when I should have multiplied. The surface gravity is actually 10 times stronger than on Earth.
Then we are about to meet very short and thick beings.
It looks like a very cold planet.
Maybe they'll be furry people or furry somethings.
Attention everyone, we are descending. Prepare to land.
This is the moment of truth. Will they greet us or attack us?
You will be happy to know that we are receiving welcoming signals. It turns out that their computers understand our language. They are actually inviting us to land, and we have accepted the invitation. The dream of our ancestors is about to be fulfilled.
We are about to learn what extraterrestrials are really like. How will we communicate? Maybe the language of friendship is the same everywhere in the universe?
The sight of the stars make us dream. Is it fantasy or a vision of the future? Perhaps your own descendants will make this journey and befriend beings from another corner of the universe.
Thank you so much.